Somehow, I am going to turn this pile of stuff into a bright nickel electroplating station. Stay tuned to find out how. So here's the plan of attack. First we need a container to hold the solution. That seems to work. We need a power source. We need some nickel strips. So what the plan is, cut this out. That fits the top there. I'm going to cut a hole in there. And around the interior, this is high density polyethylene. I'm going to bend this so it fits around that lip. Nice and straight. And then I will plastic weld this to the inside of that hole I'm going to make. These rib nuts, and put them in at a couple of spots. I'm going to do 4 of them. Drill a hole in the nickel there. That'll get screwed to the rib nut. We'll bend that over so it goes down into the bottom too. Be L-shaped. And then we will, back of the rib nuts will have thing for wires. So we'll wire all those nickel plates together. And on the top of that, drill some holes. This 1/8 inch brass rod will go through. And so they will be sitting crossways. And then some of these rods I have threaded already. It's a 440 thread. The parts that I'm going to nickel plate have a bunch of 440 holes in them. So I'm going to take these rods, figure out how long they need and how high the top bar is. I'll bend a little hook in them to hang them from. So I should be able to get, I'm thinking 8 parts in here all at once. Got 4 rods with the threads tapped on them already. Hook up the wires to the nickel plates and the support rods. Turn on the power and away she goes. So to make that ring, I'm going to take these strips that I cut out and hit them with a heat gun. And try really hard to not melt my bucket while I'm at it. Stuff's kind of fun to play with. I've made a few parts for scooters out of this stuff. It's pretty strong, easy to form, and it smells wonderful when you melt it. Oh yeah. I'm just going to hold that a little over bent while it cools. When you let it go, it'll spring back. I think I need to heat her up just a titch more. Still wanting to wander back to original shape. Something you can do, hold it up against something cold, will transfer heat into that other part. Well, it's holding pretty well. I like it. I'm going to cut a piece for that missing part, and we will weld that in there. Well, this is a welding table, so we must do some welding. How are you going to weld plastic, you say? Soldering gun. I've taken a piece of, I think it's 10 gauge wire, copper wire, bend it around and pounded her flat. I've come up with a technique for doing this. I go through, kind of push it in almost all the way through. You're kind of stitching it together. And once you get it all stitched, flip it over. It's the flat side. Kind of pushing the ridges that you melted up out of there down into the holes that you melted into there. You melted both ends into each other. It's a pretty strong joint. Use this quite a bit. I do have a big plastic welder that uses the hot air and the plastic rods, but most of the time I find this does the trick just as good. Look at that. This one, the clamp's kind of in the way. I'm only going to be able to get halfway through. I got the clamp kind of across that joint. Flip the soldering iron over so you got the flat spot. Gonna iron it out. So I've got her flipped over, reclamped. Now we can do this side. Notice my little seam here? Cut the ring out on the bandsaw. I think I'll be able to weld that back together too. So, we've got a ring. I didn't want to do anything to the box because the lid has a gasket. And I plan on leaving the solution in there and putting the lid on when I'm not using it. So I can just pull this out, put the lid on. Still safe. Well, I can go ahead and weld this all up now. Everything is now welded up. Went through and welded all the seams. I've drilled a few holes in the wrong spots. And the next step is to the attachment points for the anodes. The nickel anodes, we're using a rib nut. I've got that counter sunk in that side just to get it spaced out so it'll catch this eye connector as the washer. So I'll show you how we do that. Things happen really fast when you're drilling in plastic. As soon as that drill bit catches, it just dives right through. Now we'll switch over to the size drill bit for the shank of the rib nut. This is the one that'll just go right through. I'm going to hold back as much as I can. Alright, now for the countersink. This was featured in my cool tool section. This is the first time I've used this in probably 15 years. This is a piloted spade bit that I made out of some 01 drill rod. So the round pilot goes through the established hole. Then the spade bit drills a countersink with a flat bottom. And that's perfect for what we need for the rib nut head. Now this material is so much thicker than what the sheet metal that rib nuts are typically used on, so that's why I have to countersink them. I need to go about halfway through. One little more shot. There, that looks pretty good. How good a job that thing does. Now we can install those rib nuts. Now because of the countersink, we need to add a couple of washers in there. I think it was 2. For those to go down in that hole. Then eye connector for the electrical. And it's just that easy. So now, show you how these all go on. fits right down in the bucket. All right, for wiring up the anodes, I conducted a little experiment here. Cut a groove in the plastic, laid this wire. This has a silicone insulator, so it was safe to go down and kind of melt that into the groove to keep it contained. So now I'm going to go through and wire up all of this stuff. I'm going to start at one end here. So I sat and thought, trying to figure out how to get the cathode mounted on there. So the parts will hang from these little rods here. But how to mount those darn things? And I came up with a way. I have taken some copper wire, twisted some loops in them, and I'm melting those down and sinking them into the plastic. And when I'm done with all that, I'll drill some holes where those rings come through in this little thin piece of plastic, cap it all off so it'll look nice and pretty. Anyway, I made a new tip for the soldering iron, and here's how I'm doing this. Put that on that copper wire. Thermodynamics, it heat transfers the copper wire. And it melts into that plastic. And I've got some needle nose vice grips set to the depth of just the plastic. So once that starts melting in, just clip on the vice grips and it squishes it right down flush with the top of that plastic. Hey, let's try something fun here. We are doing just continuity. I'm going to put that on that terminal. Let's test this over here. See, that's, even though that one's just floating, it's getting electricity clear over there. Make sure we don't have it on our anodes. That's all good. Here's our anode. We are good electrically. So now, clean off this bench. I'm going to drill some holes for those loops to go through. And then I am going to plastic weld this cap on the top so it's all nice and pretty. Well, I have everything welded up now. Got the inside seams all welded. Outside seams all welded for that top piece. And it fits right on there. Let's get this thing ready to do some plating. Okay, let's try this out. For on this side, we have the electro cleaner solution. I've got one of my hooks that I made attached to this alligator clip. So I'm going to attach that to the negative side of the power thing. The anode in the electro cleaner solution is a strip of stainless steel. We are set at 6 volts. And that only needs to go in there for about 30 seconds. You can see it, but it bubbles up. Real fine bubbles. This gets rid of any grease or residual dirt that is on there. I polished these rods with a buffing wheel, and then I gave them a ride in the ultrasonic cleaner to get rid of all the wax from the buffing compound. And now this gets rid of anything that's left over. Now I'm going to disconnect the electric from that. I've got a bucket of clean water off to the side here. Good swish around and rinse. I'm going to give her a shot with the air hose. Okay, that should be 100% clean. So now, I've got this on this alligator clip. I'm hooking that to the negative side. I've got the power supply set at 1.6 volts. Let me just set that there so everybody can watch what happens here. I can figure out how to get this set up. Alright, the top number is volts, bottom number is amps. We're set at constant volts. And in we go. Just going to wiggle it a little so there's no bubbles. Now watch the amps. See that starting to go? That means this has established an electrical connection through the solution. And the nickel ions in the solution and in the anodes are getting attracted to the part, deposited on the part. Show you just how fast this goes. That's already turning. So this is a bit of experimentation here. I've been doing 2 of my brass parts at a time, just in a bucket with the anodes clipped to the sides. And on those, I'm running the part at 1.6 volts for 20 minutes, and the amps will eventually work its way up to about 0.22 or 0.23 by the end of the bath. I don't know if just one little part's going to make that amps, and I don't need these parts plated as heavily as I do my parts. I'm just plating these to keep the brass from corroding, so this is probably good enough. Get that out of the way. And we've got a nickel plated part. So disconnect that. Give her a rinse in the clean water. I've found that rinsing them off and then blowing the water off will keep them from getting spots. Grab another one to show before and after. Look at that. That's pretty darn cool. I think this is a success. Well, we are at the moment of truth. I am a little bit concerned that this solution may be contaminated. I saw a few spots on the parts that I did, but it was on the first couple, so maybe I coated the first couple with the contamination and now it's gone. But here's the one part that I'm gonna do, and the other part. These little jobbers go together like that. Anyway, this is how I've been doing them, just as a pair, and we set up this tank to do 4 pairs, so 8 parts. But because of my concern about the contamination, I am going to limit myself to just doing 2 for the first trial. So that's been about 20 minutes, a little less. Part of this electroplating process, there's a line of sight component to how the plating works. And before, I didn't have coverage on all 4 sides and the bottom. So I was turning the parts and pulling them out and turning them. So I may have been, every time you take the part out, the amps kind of starts over. I think that's why the amps went so high. They went up to, what was it, 31? 30, 31? And I probably didn't need to leave them in as long since I didn't mess with them while they were in there. So I'm not seeing any funky little watermarks on them like you get when your solution's contaminated. These look pretty darn good. There's the finished product. I think that's a keeper. So I went ahead and loaded 6 parts in there, and the amps really shot up. I think the amp thing is cumulative. It is based on surface area of what you're putting in there. So if I was getting 0.2 amps with 2 parts in there, I'm getting 0.6 amps with 6 parts in there. So that seems about right. Those first ones did seem a little heavily coated, so I'm gonna back the juice off just a titch. Now we're back down to that 0.2 amps. I think that's probably a good place to be. We'll let these cook for a while and see what happens. So this whole thing worked out pretty good. We made some nickel-plated parts. We made a tub for the nickel plating. So I'm going to make another tub kind of similar to this, not quite as complicated, for the bath process. And I think I'm going to do one more tub with some fancy water circulation for the rinse process. I'm going to build a box that the whole thing goes in. It closes up. So now that we're done with this, I can just take this part out. And it needs to be rinsed off. Wonder where I could do that. Look at that. And then we put a lid. This tub actually has a gasket in it, so I wouldn't want to go running down the neighborhood streets with it, but that'll hold my juice. We'll do another one for the etch bath. Make a compartment to hold everything. And we are going to be set up for bright nickel plating. So I actually learned quite a bit with this process. The voltage versus amps drawn, it seems to be dependent on the amps rather than the volts for doing the plating. The first one of my parts that I did, I think I got the plating on a little heavy because I left the volts where it was and we had all those extra anode plates in there. So when I did the other parts, where I did 6 at a time, I set it to constant amperage, constant current, and those turned out really good. So thanks for watching. Make sure you subscribe and like the page, and we'll see you on the next build. Thanks.